All right, we're taking our quiz today, so one last check, looking over these things, answering a couple questions before we get going. Find the maximums, minimums, and points of inflection of this function. So to find maxes and mins, we are going to look at the first derivative. So if I find the first derivative here, negative 12x cubed plus 24x squared. That's my first derivative. Lillian, what are you going to do with that first derivative now? Set it equal to 0. What'd you do to solve that? Good. Negative 12x squared, that's what they have in common. So if you took a negative 12x squared out of that thing, you'd be left with x. Negative 12x squared out of that thing, you'd have minus 2. Set each thing equal to 0. Boom. Okay, so when I make my sign chart, f prime of x, what do I have to do a little bit different on this sign chart than most? Good. I've got endpoints here. Make sure you cap your number line. It is not a arrowed number line. It is a capped number line. Okay, we are going between negative 2 and 4. I got 0. I've got 2. Okay, so this is my function. This is my first derivative, so I'm plugging into that. One of these spots is not going to change signs. Which one do you think, 0 or 2, is not going to change signs when I plug in numbers? Why 0? Because the 0 is squared. To find this term, it was squared. It's not going to change signs. Still check it, but if the other ones don't change signs, you made a mistake. So plug in negative 1. If I plugged in a negative 1 here, it would be negative. If I plugged in a negative 1 there, it'd be negative. Negative times a negative is a positive. If I plug in 0, we said it's not going to change. So if I plugged in 1, this would be negative. If I plugged in 1, that is still negative, and that's positive. If I plug in 3, 3 would be negative, and okay, that would be negative. So that's my answer. The question was, where are the maxes and the minimums? Show me with your fingers. Where is your maximum going to be? Good. We have a maximum at x is equal to 2. Okay, f prime is positive, and then f prime is negative. That makes this right here a maximum. Where am I going to have a minimum then? I do. In fact, I have 2 minimums. Where are my minimum is at x is equal to negative 2 and 4, because you have some value and then your slope is positive after it. If your slope is positive, you're increasing. You're going up and up and up. And then you're going down, 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 and then stopping. So both of these spots are considered minimums. Okay, they're not relative minimums, but they are minimums in terms of they could find the lowest value. Don't forget about endpoints when we're talking maxes and mins. Questions there? Cool. Now we're going to talk about points of inflection. If we want to talk about points of inflection, that is a second derivative question. So let's find the second derivative. F double prime of x. Negative 36x squared plus 48x. We're going to take that second derivative. We're going to set it equal to 0. Caden, what'd you do from there? Negative 12x. So if you took that out, you're left with 3x plus 4. Sure. X is 0. X is negative 4 thirds. It's, It is minus 4 because I factor out a negative 12. Duh. That's why I was testing you to see if you could check it. Good job. You guys passed. It's positive 4 thirds because I'm going to solve it. 3x minus 4, set it equal to 0. I just want to see if you're locked in before we take this quiz. I'd hate for you to make silly mistakes with negative signs. Okay, it's 4 thirds. So on my sign chart, I've got 0. I've got 4 thirds, and I do still have capped ends. Negative 2 and a positive 4. Okay, we're plugging in numbers into this second derivative. We're plugging into that, so we could plug in negative 1. If I plugged a negative 1 in here, it'd be positive. A negative 1 in here would be negative. So this is negative. If I plugged in 1, this would be positive. If I plugged in 1, I'm sorry, this would be negative. If I plugged in 1 here, that'd be 3 minus 4. That would be negative. So this is positive. A number bigger than 4/3. So like 2. If I plugged in 2 here, it'd be negative. If I plugged in 2 here, it'd be positive. Boom. How many points of inflection? Show me the fingers. How many points of inflection does this graph have? Are the end points going to be points of inflection? Never. That is never the answer. Endpoints are not points of inflection because points of inflection happen when the second derivative changes signs. Questions with that? Let's just do some practice. We got some time here on your bell work. Do this problem right here for me. For what values of x does g of x have a point of inflection? If you have your brain on, you can do this problem in about 10 seconds. Okay, if you don't have your brain on, it might take you a little bit longer. I don't care which way you do it, but get an answer. Go. How many points of inflection is this graph going to have? Just looking at it, you hopefully should be able to see that there are only going to be 2 points of inflection. If I'm making my sign chart, what values can I put on here? 0, 3, -4. Yeah, good. -4, 0, 3. It's non-capped. But then we're going to plug in. How did I know before I did anything else that 3 is not going to end up being a point of inflection? It's not going to change signs. It's squared. Okay, pick a number, and you could still do it. If I plugged in 1, this would be positive. This would be positive because I'm squaring it. This is always going to be positive because it's squared. And then if I plugged in 1 there, it'd be positive, so this is positive. If I plugged in a number bigger than 3, like 4, this would also be positive because that would be positive, that would be positive, this would be negative, that would be positive. There are 2 places where I change signs, so the only 2 points of inflection are -4 and 0. Let's do another one. All right, let g of x be equal to that equation there. The maximum of g's over that interval occur at what x values? Figure it out. Go. Are solving this thing. So if we want to find maximums, we took the derivative. We set it equal to 0. We solve. Yeah, just kidding. X is equal to plus or minus 2. So what numbers do I need to put on my sign chart? Plus or minus 2. And what else? And the endpoints. Don't forget about them. -4 to 5. We've got -2 and a +2. Okay, we're plugging in some values. We are doing g prime of x. So we got to find some values to plug in. If I plug in a number between -4 and -2, like -3, this is positive, that's negative. So show me with your fingers, where are the maximums gonna be? Where are the maximums going to be? The correct answer is -2 is a max and 5 is a max, because understand what's going on. It's g prime. G prime is positive, means I'm increasing. Then -2, it's decreasing. G prime is negative. And then we're increasing again. So those 2 places right there are the maximums. Yeah, I had to go back and double check because I was confused what was happening there, Nathan. We're good to that point. Concavity, we can do concavity. Oh, let's do that one real quick. Figure out where f is increasing. They gave me the first derivative here. I want to know when f is increasing. So what has to be true about f prime for f to be increasing? F prime is positive. That's all we're trying to figure out, when f prime is positive. We're making a sign chart. What numbers are going to go on this f prime sign chart? When what? 0 and 2, both of them, because it's when the derivative is 0. Well, when would it be 0? When the top is 0, so we would take x minus 2 and set it equal to 0. That would get me 2. And then when it's undefined, undefined is when I'd get 0 on bottom. So if x were 0, that would also get me undefined. And we're picking numbers. If we picked 1 here, that would get me a negative on top and a positive on bottom. that would be positive, that would be positive. So when is it increasing? On the outside intervals when it would be increasing. Just some good practice with some different things. We should be good to go. Let's do it. Questions before we